Is that good? Maybe I should change my background. Yeah. What if I had this background? Okay, so first, before we get into our new stuff, did everyone get the homework that I sent out?
Yep.
Yeah?
Yeah.
First of all, are there any
What were you just talking about?
questions that you had a lot of trouble on that you would like me to explain today, just to go over one more time? Are there any questions on the homework that you would like me to go over?
Wait, what were you just talking about? I just joined.
He's asking if you
No?
have any question. One more.
You guys are all good on the homework? No
Yep.
problems? Okay, that's cool.
Yeah, no problem.
So I'm gonna wait a little longer.
Myself? Yeah. Can I mute myself?
Did you draw in audio?
Yeah, I
有
did.
声音。
I did. It doesn't say. Yeah, yeah.
不要管别人，就管好自己就行了。
I don't like having songs.
你不要管谁的。
Okay,
Hi.
so let me see. Wait if there's anyone else that's coming in. Okay, so you guys said that you preferred a Kahoot last time, but I didn't really know how to get Kahoot to work on this. I'll probably figure it out next time, but this week we have another quizzes. Okay, so we're gonna get started. Share my screen, and this week I have a slideshow. Full slideshow. Can everyone see it?
Hmm?
Can everyone see the
别动，别
slideshow?
动，别动！
Yeah. Yeah.
你动了我，你别动好吗？
Volume
开
is
始
off.
了已经。
Okay, so week 2 of Prealgebra, and today we're going to be talking about number theory. And if you don't know what number theory is about basically all the really fun stuff about numbers. And if you've ever done music theory before, this is nothing like music theory. It's just okay. So the topics we're going to cover are, and I know you all might have seen these before. We're going to cover multiples, divisors, primes and composites, multiple rules, divisor rules, prime factorization, and greatest common factor, and least common multiple. And that sounds like a lot, but don't worry, we're gonna get through them. Okay, so let's start with multiples.
That bad.
So what are multiples? Well, multiples, the definition of a multiple is that if we have some number a, and this number a has to be an integer, okay? If you don't know what an integer is a whole number, but that includes the negative numbers and 0. So that means we can have negative 17 as an integer, negative 5, 0, 3, but not 1/2, not anything like negative 3/2 either, okay? So those are all integers. And if we have some integer a, the multiples of a are that number a times another integer n. Okay, for example, if I had number 4, and I wanted to write out all the multiples of 4, I would go 4, 8, 12, 16, right? But since this n can be any integer, n can also be 0. So 0 is also a multiple of 4, and negative 4, and negative 8, and negative 16. Okay, so I'm sure most of you have done multiples before, but it's really important to remember that multiples include 0 and negative numbers. Okay, so now we know what multiples are. I have some problems here for you. And if you don't have pencil and paper yet, maybe you should get some. And okay, I'll give you a few minutes to work on these. Okay, are you guys done?
Yeah, I'm done.
Okay. So I'm going to go over the first problem here. Which of the following is a multiple of 3? So basically, if we multiply 3 by some number n, we should get one of these. Okay? If you know your 3 times tables and your multiplication facts, you'll know that 27 is 3 times 9. Okay? And what is the sum of the two smallest multiples of 6 greater than 100? Well, if we do some work here, we'll realize that there are 102 and 108. But how do we know that? One thing we know is that 60 is a multiple of 6, and also 120. And if we subtract 6 from 120, we keep subtracting 6. Wait a second, did that one wrong, 114. Keep subtracting 6. We'll see that the smallest two are 102, 108, and our sum is therefore 210. Okay? So what is the only integer that is a multiple of every integer? Well, if we write out, let's say we want the multiples of 7. 7, 14, 28. We can also go in the other direction. 0, negative 7, negative 14. Let's do it for 9. 9, 18, 27, but also 0, negative 9, negative 18. And the cool thing here is that we can see that 0 is in both of them. So the only integer that is a multiple of every integer is 0. Okay? That's a pretty important thing for you guys to remember. Now we have divisors. Well, what are divisors? Basically, divisors are the opposite of multiples, just like multiplication is the opposite of division. Okay? And divisors are basically, if we take a number a, this number a can have a bunch of divisors, that if I divide a by n, I get an integer. So let me give you some examples. If we have the number 12 and wanted to find the divisors of 12, well, we're going to have 1, 2, 3, 4, not 5, 6, 12. But we can also have negative numbers here. -1, -2, -3, -4, -6, and -12. Okay? Because if I divided 12 by any of these negative numbers, I would still get an integer result. So divisors also have positives and negatives. But here's the question, is 0 a divisor of 12? Do you guys think that a 0 could be a divisor of 12?
No.
No, why not? Well, if I divide 0 by 12, that is not going to work. We can't divide by 0 according to the laws of mathematics. If we do that, we're going to get sent to jail. So 0 is not a divisor of anything. Okay, that's purely because of the fact we can't divide anything by 0. Okay, so those are divisors. And the cool thing here is that if I write out all the divisors of 12, all of these numbers have 12 as a multiple. See? 12 is a multiple of 1, 12 is a multiple of 2, 12 is a multiple of 3, and all of these things. Okay? So this goes to prove, again, that divisors are the opposites of multiples. Okay? Let's see some problems with divisors. A few minutes to do these. Okay, is everyone done?
Yep. Yes.
Okay. So let's go to the first one. 279 is a multiple of 3, 9, and 31. Is this enough to show that 3, 9, and 31 are divisors of 279? Yes,
Yes.
because multiples are the opposites of divisors, right? And if we have 279 as a multiple of these numbers will be divisors of 279. Okay? So yes.
Yeah.
How many divisors does 20 have? Well, the easiest thing to do here is write them out. 1, 2, 4, 5, 10, 20. 1, 2, 3, 4, 5, 6.
Oh.
Is that the answer? No, that's not.
No.
We forgot to include the negative divisors.
So we were both wrong.
Each of these has a negative. So in the end, we're going to have to multiply our number by 2, right? Because we have the exact same amount of negatives as we do positives. So we actually have 12 divisors for 20. Okay? Are there any questions? No? Okay. So this one, the last problem is kind of fun because it's more like a riddle, right?
Yeah.
And what is the problem here? The 7, okay. Amanda arranges the digits 1, 3, 5, and 7 to make a 4-digit number. The 7 is next to the 1, but not the 5. The 3 is next to the 7, but not the 5. And the 4-digit number is divisible by 5. What is the number? The first thing I see here is that divisible by 5. So, knowing my divisibility tricks for 5, I know that anything divisible by 5 must have the last digit 5 or 0, right?
Yeah. And
0 is not one of my choices here, so 5 has to be the last digit. Okay, drawing out my 3 spaces for the other digits. I have the 7 is next to the 1, but not the 5. So 7 cannot be here. The 3 is next to the 7, but not the 5. So 3 can't be here either. So the only other number that can be here, 1. Okay? And the 7 is next to 1, and the 7 is also next to 3. So to have the 7 next to the 1, I have to put the 7 here, and the last spot goes to the 3. This is the number. Okay? But I think that's more like a riddle. The only really math part here is the divisibility. Okay? The next one. So now we have prime versus composite numbers.
Oh, I already know this, but
So what are prime numbers? Well, by definition, prime numbers are numbers with exactly 2 divisors, which are 1 and itself. All right? So,
wait, so
common
they're
prime
basically
numbers,
factors.
2, 3, 5, 7. Yeah,
I do like factors.
factors
Yeah.
is
There's
another
like-
word for divisors, and factors and divisors are the exact same thing. Okay? 2, 3, 5, 7, 11, 13, ... right? And composite numbers have more than 2. More than 2 divisors. All right? So these are numbers like 4, 6, 8, 9, right?
Yeah.
And something important to note about composite numbers are that all even numbers
Have to be. Other than 2.
Yeah. Other than
all
2.
even numbers are composite
Because two factors.
except for 2. Because why is this true? Well, all even numbers have 2 as a divisor, right? And if we count the divisors now, we have 1, 2, and that number. And we might have something else too, but we already have 3 divisors, so that must mean the number has to be composite. Okay? Let's do some problems with prime and numbers.
Okay, I'm done.
Done.
Is anyone else done? Okay. Which of the following numbers is not prime? Well, I can see immediately, without even considering the other numbers, that 38 is the only even number. And 38 has to be composite. So this is my not prime number. The same thing goes for the second question. Okay, and as for, is 1 a prime or a composite number? The answer is actually neither. Because the definition of a prime number is exactly 2 divisors. The definition of a composite is more than 2. Right? And 1 only has itself, right? So it only has 1 divisor. So it can't be either one of these. And if you're like, hey, what about negatives? Well, when we're talking about primes and composites, we're only going to talk about the positive divisors, okay? So yes, 1 does have 2 divisors if you include 1 and -1, but since we're only talking about positives, it only has 1, okay? So now we have some rules about multiples, okay? So if I had a multiple of 3, let's just say 15, okay, and I added that to another multiple of 3, 21. Is my answer going to be a multiple of 3? Well, yes. It has to be a multiple of 3. So why is that true? Well, remember how back in first grade when we did even numbers and odd numbers, we would group kids together? Well, we're going to do this too. So let's just say we have a group of 3 here, another group of 3, right? And this is the number 15. We don't have any remainder here, right? We have no outliers. And the same thing goes for 21. We're not going to have any outliers, right? And so if we add these two groups together, we're not going to have any outliers either, okay? So that's why if I have a number a as a multiple of 3, or a multiple of anything actually, n, and I have b as a multiple of n, then a plus b has to be a multiple of n. The same thing goes for a minus b. Okay, both of these things have to be multiples of n. What if I had a slightly more challenging problem, but also with multiples? What if I had, let's just say a has a remainder of 4 when divided by 6, and then b has a remainder of 5 when divided by 6. What's the remainder when a plus b is divided by 6?
3.
What's the remainder when that's divided by 6? Does anyone have an idea? 3, yes, it is 3. Well, how do we visualize this? Well, let's just say we have the number a, right? And let's group them into 6, right? And who knows how many groups of these I have, dot, 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 dot. But I'm going to have 4 outliers because that's the remainder. 1, 2, 3, 4, right? Let's say we also have the number b and we have a bunch of groups, dot, dot, but the only thing we care about are the outliers. We have 5 outliers, right? And if we add these two together, the groups stay within their groups. Nothing's going on there. So all we need to care about is adding these outliers. We have 4 plus 5 equals 9 outliers, okay? If we have 9 outliers in the end, we can group 6 of them together to make a group. So 9 minus 6, we have 3 left as a remainder, okay? And this is a really, really popular kind of question in math competitions. And in the future, instead of saying this long notation like this, we're going to use something called mods. But that's a topic for another day. Okay? Let's have these problems here.
Okay, done.
Okay, is anyone else done?
Done.
Done? Okay. Go over these problems. I have the numbers 3, 5, 8, and 9. I pick 2 numbers and add them together to make a multiple of 3. So which 2 should I pick? Well, using what we just learned, if I have a number a, that's a multiple of n, and b, that's a multiple of n, then a plus b is a multiple of n. one thing I could do, I could try out all these pairs, all the possible pairs, but that would take a lot of time, right? So we gotta think kind of smart here. We can see how both of these numbers, 3 and 9, are multiples of 3. So if we add them together, they have to be a multiple of 3. Okay, so these two numbers are the ones we're gonna pick. And what if I subtracted them? Well, the logic is the same. It doesn't matter if I'm adding or subtracting, both of these will make a multiple of 3. Okay, so the answer is 3 and 9. Second problem, if I had a number that gave a remainder of 2 when divided by 5, and another number that gave a remainder of 3 when divided by 5, what is the remainder when I divide their sum by 5? So, how to visualize this number? I'll call the first number A and the second number B, okay? I'm going to have some groups of 5 here, 1, 2, 3, 4, 5. I'm going to have these completed groups, and I don't really care about how many they are. But what I do know is I have 2 outliers in A, and in B, I have 3 outliers. Okay, and when I add these two numbers together, these groups are not going to jumble up with each other. They're going to stay intact. So I don't even need to care about these. All I need to care about are the outliers. I have 2 here, 3 here. Adding them together, I have 5 outliers. And since I'm dividing by 5, I can evenly make a group of 5 right here and there. So I can make this into a group. So now I have 0 outliers left. And that is the remainder.
Right now.
Remainder. Okay?
Sorry.
And the next problem is really, really similar too. I had 2 numbers, one of which gives a remainder of 3 when divided by 6. And their sum is divisible by 6. What is the remainder when I divide the other number by 6? Okay, so one thing when I see divisible by 6, I know that's a remainder of 0. Okay? So one of the numbers gives a remainder of 3. So to visualize this number, I'm going to have these groups of 6. I don't even need to care about what they are. Okay? And I have remainder of 3, which is the outliers. Okay? And I have another number with a certain number of groups of 6 and a certain number of outliers. If I add these two numbers together, I'm going to have
What?
outliers
I
left.
read the ball.
That means I made a group of 6 when I add these together. So that means I have to have 3 here to make a group of 6, because 3 plus 3 is 6. If I add these together, I have a complete group and I have no remainders. So if I divide the other number by 6, remainder 3. All right? Are there any questions about how I did that?
No.
No?
It could be a multiple of 6, and then you just add 3. It doesn't have to be 3.
Could you say that again?
It could be a multiple of 3. Sorry, a multiple of 6 plus 3. Any of them actually. So it could be 15. It could be
Yeah, those are examples of what this number could be.
yeah.
But the remainder, that's all I care about because that's what the problem asks. Okay? Now I have divisibility rules, and I think these are a lot more fun. And I think we all know this divisibility rule too, okay? If a number is even, then it's divisible by 2. Okay? But for 3, if the digits sum to a multiple of 3, if I add all the digits together and I get a multiple of 3, then this number is divisible by 3. Okay, so why don't you guys test this one out with number 258, okay? First try dividing it by 3 just normally, and then try using the divisibility rule right here to see if it's divisible by 3. Okay? Alright, if I divide this normally, I would do this.
86. Right.
Okay?
Right.
Correct, no remainder, good. I don't really care about what this number is anyways, because I only care about divisibility. And if I add all the digits together, 2 plus 5 plus 8, that equals 15, and 15 is a multiple of 3. So that also works. So if you see here, we don't always have to divide like this. This takes a lot of time and a lot of effort. If I add the digits together, that's a lot easier to do. Okay? And about 4. If the last 2 digits in a number are divisible by 4, then the whole number is divisible by 4. let me show this with an example. 2, 7, 8, 9, 6, 2, 4. Okay? Instead of writing this number as it is, I can turn this into 2789600 plus 24. Does anyone have any questions on how I did this? Any questions?
No.
See this happening? Right?
No.
I just
I
took the
see-
24
so
out and I
I
have.
see it. I just have no questions.
Okay, so as we can see here, this number has 2 zeros at the end, which means it is divisible by 100, right? And as we know, since 4 is a divisor of 100, this number is definitely divisible by 4, right? So we don't even need to care about anything in front of the last 2 digits. So all we need to care about are the last 2 digits. 24 is divisible by 4, so correct. This number is a divisor of 4. A multiple of 4, actually. Okay, so that's the one for 4. And the rule for 5 works really similarly as well. Ends in 0, doesn't work similarly, but I'm sure all of you know it. Ends in 0 or 5. And for 6, we don't have a special rule for that. It's just that 6 has to satisfy the rules for 2 and 3. Okay, this is because 6 equals 2 times 3. So if 6 satisfies the rules for both of them, then if the number satisfies the rules for 2 and 3, then it's definitely divisible by 6 as well. Okay? And for 8, we have to just test the last 3 digits. And 9, similarly to 3, we add all the digits together and see if they're a multiple of 9. Okay, so let's put these divisibility rules to use with some problems. Okay? If you don't know how to do the last one, that is fine, because this one is a pretty challenging problem.
Okay, I'm done.
Okay, what about everyone else? Done?
No.
Not yet? Okay. We can wait for a little longer. So if I'll just review the divisibility rules here on the bottom. 2, even 3 digits. Add 4 last 2 digits. 5, 0, 5, 6. And then 8 last 3 digits. 9 digits. Add to multiple. Okay. So I'll go over the answers now. So I have the number 2865, which of the following is not a divisor? The first thing I can rule out, though, is 1. 1 is a divisor of everything, right? And now I can also see that this ends in 5. So 5 is a divisor, so that is not the right answer. So Now I just add the digits together to see if they're divisible by 3, right? 2 plus 8 plus 6 plus 5, 21. Yes, it is divisible by 3, so 9 must be our answer. And we can also confirm that by seeing how 21 is not a multiple of 9. Okay. Next problem, I have the number 2379261, which digits sum to 30, which must be a divisor of this number. Okay, the first thing I know is that this number is odd. No way it's 2. And also, it doesn't end in 5 or 0. So it can't be either of these. It's 3. Right? And we can confirm this by seeing how 30 is a multiple of 3, and therefore it satisfies the condition for 3. Okay? Now, what is the remainder when this whole lot is divided by 4? Well, if we look at the 4 rule, all we need to look at are the last 2 digits. We don't even need to care about anything in front. We just do 74 divided by 4, the old-fashioned way. And we do 4, 8, 2. Remainder 2. All right? Now the hard problem. If the number with d as a digit, 72d2, is divisible by 6, what is the largest possible value of d? Okay, so what is the rule for divisibility by 6? Satisfies for 2 and 3. First, let's check for 2. Well, 2 is already certain. We already know that's divisible by 2 for sure. So we just need to test for 3, right? So somehow, when I add the digits together, 7 plus 2 plus d plus 2, it has to be a multiple of 3, right? And if I add the lone numbers together, I'll get 11 plus d plus multiple of 3. So I can basically just test out values for this, right? If I want to get to, let's say, if I want to get 18 as my multiple of 3, well then d is going to be 7, right? Because 11 plus 7 equals 18. If d equals 7, that works, right? Let's see if we could go higher. What if we choose 21 as our multiple of 3? Well then d must equal 10. But since 10 can't be a digit, right? We can't have 2 digits in 1 digit. That can't work. So we know that 7 must be our maximum. So 7 is the answer. All right? Does everyone get that?
Yeah.
Yeah.
Prime factorization. We're almost at the end. So prime factorization is basically turning any number into like a lot of primes multiplying. So for example, I can turn the number 20 into 4 times 5, and then 4 equals 2 times 2, right? But 4 is not prime yet, so I can't stop there. I have to turn 4 into 2 times 2 times 5. So prime factorization is 2 squared times 5, okay? And if I were to do 24, well, I know that 24 is 4 times 6, right? And neither of these are prime, so I have to turn each of these numbers into primes. So 4 equals 2 times 2, and 6 equals 2 times 3. So I have 2 to the third times 3. Okay? So those are the prime factorizations, okay? So does everyone understand how these work? Okay. Skip this slide for now. So why do we even need to use prime factorizations? This is for least common multiple and greatest common factor, okay? So what is least common multiple? Well, the least common multiple between two numbers a and b is the smallest number that is a multiple of both of them. Okay, for example, if I had numbers 6 and 9, for example, well, I would have the multiples of 6 are 6, 12, 18, 24, and 9, 18, 27. And I immediately see that 18 is common to both of them, so this is the least common multiple of 6 and 9. Okay? What about greatest common factor? Greatest common factor is the greatest number that is factor of each of these. Let's go with 6 and 9 again. Let's look at the factors of 6. 1, 2, 3, 6. 9, I have 1, 3, 9. And as you can see, 1 is a factor of both of them. but 3 is 2. So 3 is the biggest one, so 3 is the greatest common factor. Okay, so why do we use prime factorizations? Well, let's just say I had a number 2 to the 7th, 3 to the 6th, and I had another number 2 to the 3 to the 4th, and 2 to the 9th. Okay, what is the least common multiple of these two numbers? Well, the trick here is that I look at the powers of each of the primes here. We have to first make sure that these numbers are in their prime factorizations. And yes, they are. And so I'm going to look at the primes here. Look at the powers of 2. I have a power of 7 here and the power of 9. Okay? If I wanted to find the least common multiple, then I would take the larger one of both of these. Okay, I would take the larger one of 7 or 9, and that is 9. Okay, now I'm going to look at the 3's. I'm going to take the larger power, again, it's going to be 3 to the 6th, and this is our least common multiple, right here. Okay, and for GCF, if I wanted to find the GCF of these, then instead of taking the larger one, I'll take the smaller one. Okay, I have a 7 and a 9. I'm going to take the 7 for greatest common factor. And for 6 and 4, I'm going to take 4. So this is our greatest common factor. Okay? So this is a quick and easy way to find the least common multiple and greatest common factor of really big numbers like these, right? I don't know what these are. I don't think you know what these are. Okay? Let's do some problems with these. So for the first one, you could just bash it out. That's like what we like to call, we just write out all the values. But the smarter way is to prime factorize each of these, okay? And then you use the prime factorization method to solve. Okay. So let me just walk through this one. 32 is 4 times 8, right? 2 times 2 times 2 times 2 times 2, right? So the prime factorization is 2 to the 5th. What about 48? 48 is 12 times 4, 2 times 2 times 3, times 2 times 2. So I have 2 to the 4th times 3, right? And for the GCF, let's start with that. We're going to take the smaller power. So let's say we have two 2's here. We have a power of 5 and a power of 4. I'll take the smaller power, okay? Well, I don't have a power of 3 here. What do I do? Well, this is just like multiplying by 1, right? And what is 1? Well, 1 is 3 to the 0 power. 3 to the 1 power here. Again, we're taking the smaller one. 0 is smaller than 1. We're taking this, and this is basically 1. So our answer is 2 to the 4th, 16. Okay? What about LCM? I'm going to take the bigger one of them. Now, oops. 2 to the 5, 2 to the 4. Okay, I'm going to take the bigger one. 5 and 4, I'll take 5.
Okay.
And again, 0 and 1, I'll take 1. So the answer is 32 times 3, 96. Okay? So I think this is the more efficient method to solve. Okay? And I think we have time up.
Good.
And if you want to stay and do these problems, you can stay and I'll go over them. If you have just a little amount of time left to stay. If you have to leave, then okay, you can leave. Okay, let's look at these. If you get the GCF and LCM for these, they're going to be pretty big numbers, so don't mind about like multiplying them out. Just leave it there. Okay, it doesn't seem like we have time to do the quizzes either, so how about I start class next time with the quizzes? Someone's doing their work on the screen here. All right. Okay, we're gonna go over the second problem here. And for GCF, all I need to do is take the smaller power out of each of them. So I have 2 to the 7th and 2 to the 9th. I'm gonna take 2 to the 7th. I have 3 to the 11th and 3 to the 10th. I'm gonna take 3 to the 10th. What about 5 here? Well, I technically have a 5 to the 0 here, right? So I'm gonna take 5 to the 0 instead of 5 to the 3rd. And that's just 2 to the 7th times 3 to the 10th. Okay, if we have these really big numbers here, don't really mind multiplying them out, okay? What about the LCM? Instead of taking the smaller one now, I'm gonna take the bigger one. So now, out of 7 and 9, I'm gonna take the 9. 11 and 10, I'll take the 11. And out of 0 and 3, I'll take the 3, right? So this is our least common multiple. Okay. What about the last problem? Is anyone done with that?
Yeah.
Okay. What about anyone else? Does anyone need more time?
No.
Okay, I'll wait a little longer. I want to take a quick poll here. Who wants to stay a little longer and do the quizzes now? Or would you rather do it at the beginning of next time? Now or next time? What do you guys think?
Time.
Next time?
Yeah.
Okay, I'll do it next time. It's getting
No.
late.
No.
I'll do it next time.
But it's actually Isabel.
Okay. The last problem here, the trick here is to figure out the least common multiple of these numbers. Well, why is this true? Well, if we think about the first number that's divisible by all of these, that's basically the definition of least common multiple, right? So if we're going to take that least common multiple and add it to this, which is also divisible by the least common multiple, then we're going to have our answer, right? So all we need to do is find the least common multiple of these numbers. So what I'm going to do is I'm going to prime factorize all of them. 2 is already prime factorized, 3, and then 2 times 3, right? Then we have 2 to 2, or 2 to the 3rd. Okay, let's look at the least common multiple of these. Powers of 2, biggest one is 2 to the 3rd. What about powers of 3? Biggest one is, well, these are in a tie, but the biggest one is 3 to the 1st. Okay, so the least common multiple of these are 8 times 3 equals 24. So to get my answer, all I need to do is add 24 to this number. Let's do some simple addition. Ooh, is that? Yeah. 5, 6, 2. Okay. So that is it for today. And I'll see you guys next time. And we'll start with the quizzes next time, okay? Bye.
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 Thank you.
Bye.
Bye.
Bye.